Hi there, thank you for checking out this tutorial video on applications of linear equations. This is one of the series of videos that I have uploaded about problem solving involving two unknowns or one unknown. I have grouped the videos on my playlist so that you can easily find them. This is Mommy J and welcome to my YouTube channel. Okay, in these slides, we will be solving H problems. There are problems here which we will be using two variables, and then there is one that will be using one variable only. Okay, number 1. The sum of Charles and Wilma's age is 64. In 4 years, Wilma will be 3 times as old as Charles. How old are they now? In solving age problems, we need to identify here the time frame because there are actually present or past or future time frames that are involved in the problem. So in this case, we can see here that there's present age for Charles and Wilma. Let us assign letter C for Charles and Wilma. Present age for Charles is C and W for Wilma. Alright? Now, in 4 years. In 4 years means added 4 years from now. Okay? So, that's plus 4 years from now. In 4 years, Wilma will be 3 times as old as Charles. Now, in 4 years, their present ages will be C plus 4. So, more importantly first is to write their ages in 4 years. The age of Charles in 4 years is C plus 4, while that of Wilma is W plus 4. Okay? Now, from this equation, from these representations, we can write what is being said of it. So, there you have the second sentence. In 4 years, Wilma will be 3 times as old as Charles. Okay? So, in 4 years. Oh, by the way, in the first sentence, the sum of Charles and Wilma's age is 64. So, we can write it like C plus W equals 64. And on the second sentence, Wilma's age. So, Wilma, that's W plus 4, will be 3 times as old as Charles. 3 times of Charles' age, which is 3 times C plus 4. Okay? So, we can see here that this is the equation that is being said for present. So, present, this one. And then, in 4 years, we can see that the relationship of their ages is that Wilma will be 3 times as old as Charles. Okay, so these are the working equations that we have. Now, we can simplify first the second equation. W plus 4 equals 3C plus 12. We just distribute 3. Okay? Now, let us transpose 3C to the left side. So, that will become W minus 3C. And then this 4, let us transpose to the right side. So, that will be 12 minus 4, which is 8. Okay? Now, let us multiply the first equation, C plus W equals 64. Let us multiply this by negative 1 so that we can cancel out the W. If we have negative W, okay, it will be cancelled out with this positive W. Now, negative 1 times C is negative C. So let us write negative C here na, so that it will be aligned to this variable, negative 3C. And then, negative 1 times W is negative W. Let us write it here so that it will be aligned with W variable on this equation. And then, negative 1 times 64 is negative 64. Alright? So, these are the two working equations. Okay? So, with this, we can add these two equations so that W will be cancelled. When we add these two, it will become negative 4C. And negative 64 plus 8 is negative 56. Divide 56 by 4. So that will give us 56 over 4 is 14. So divide both sides by negative 4. C is 14. Right? So what is letter C in our representations? C is equivalent to 14 to the age of Charles at present. So Charles, we can write our final answer. Charles is 14 years old. Now, the sum of their ages is 64. So, if the sum of their ages is 64 and Charles is 14, therefore Wilma is 50 years old. So, Wilma is 50 years old. So, these are our final answers. Okay, number 2. A father is 3 times as old as his son, and the daughter is 3 years younger than the son. If the sum of their ages 3 years ago was 63 years, find the present age of the father. Now we can see here 3 persons. So the father, and then his son, and then his daughter. Okay? Now let us assign variables for their present ages. So the present age for father, letter F, for the son, letter S, and the daughter. Okay? Now, in the second sentence, we can see here another time frame. If the sum of their ages 3 years ago. Now, 3 years ago, it means that minus 3, or 3 years ago, the age of the father is F minus 3. The son is S minus 3, and the daughter is D minus 3. Alright? Now, again, let's go back to the problem so that we can now write the equation. So, the first sentence tells us that the father is 3 times as old as his son. And the daughter is 3 years younger than the son. 3 years younger means the son's age minus 3. Right? So, those are the relationships of these ages at present. Now, if the sum of their ages 3 years ago, so 3 years ago, these are their ages, 3 years ago. And then the sum of their ages was 63 years. So that means when you add F minus 3 and then S minus 3 and then D minus 3, the sum of these 3 ages is 63. Okay? Now, there are two equations, there are 3 variables, but we can actually reduce this into 2 equations, okay, by substituting equivalences. Let's say, for example, in this case, we can substitute, for letter F, we can substitute 3S. So, with this here, this letter F here can be substituted with 3S. So, So that will become 3s minus 3. Alright? We can actually eliminate the parentheses. It's just fine because this is just addition here. It will not affect the signs of the variables inside the parentheses with those positive here. Right? We just attach the positive sign later. Now, with s, minus 3 here, we can just rewrite this one plus s and then minus 3. So that's the second parenthesis. Now, with this d, letter here, d minus 3, letter d, there's equivalent of d here. Alright? So, the equivalent of d is s minus 3. So, substituting s minus 3, s minus 3 for letter d, here it is. Now, there's another minus 3 there. Rewrite it. Okay? So, that's equivalent to 63. Alright? So, again, this S minus 3 is the equivalent of letter D. The negative 3 here is this negative 3. So, we can see in this equation that there's only one variable, right? The variable S. 3S, S, and then another S here. Now, combining all these S variables, we have 3S plus S, 4S. 4S plus S, that will give us 5S. Alright? And then with the constants, negative 3, negative 3, negative 3, negative 3, there are actually 4 negative 3's. So that will give us negative 12. Okay? Equal to 63. So with this equation, we have 5s equals negative 12 transpose to the right side. That will give us 63 plus 12, which is 75. Okay? And then divide both sides by 5. Letter S is equal to 15. And that's actually the present age of the sun. Okay? That's 15. Now, if this is 15s, if s is equal to 15, 15 times 3, therefore, the age of the father is 45. And if d is equal to s minus 3 and s is 15, 15 minus 3, therefore, the age of the daughter is 12. Now, we can write our final answers in sentence form. Find the present age of the father. The present age of the father is 45. Right? So, this is our final answer. Number 3. So, we can also write, we can also use age problems with old things and thick things. Yan. Aged things. So, in this example, there's a limestone statue that is 56 years old or 56 years older than a wooden statue. Again, a limestone statue is 56 years older than a wooden statue. So that means the limestone here is the one that is or has a higher age. Okay? Now, there's another time frame. In 12 years. So, in 12 years. 12 years from now, 12 years hence, that's the meaning of in 12 years. The limestone will be 3 times as old as the wooden statue. Find the present age of the statues. Okay, now let us write first the present age, representation of present ages. So, the present age of the limestone statue and the wooden statue. Let us assign L and W for that. Right? So the present age is L for limestone and W for the wooden. And then there is a in 12 years time frame. So in 12 years, we can say that the age of the limestone is L plus 12. Normally, this is what we are going to do first when we are solving age problems. We normally identify the time frames, the present time, the another time frame, and then write these things here. If it's in 12 years, you add. If it is ago, you subtract. Okay? Now, anyway, let us move on again to the problem. Let us go back so that we can see the relationship of these ages. A limestone statue is 56 years older than a wooden statue. So that means we can write the first equation as limestone is 56 years older. So 56 years older than the wooden statue. Okay? In 12 years. So, in this second equation, dito naman tayo titingin. Because it's in 12 years, it says that in 12 years, the limestone, so that's L plus 12, the limestone will be 3 times as old as the wooden statue. 3 times as old as this. So that will be 3 times W plus 12. Right? So these are our working equations. Now let us first simplify the second equation. L plus 12 equals, distribute 3 to W and plus 12. So that will give us 3W plus 36. Alright? And then, what we can do here is to write all the variables on the left side. So this will become L minus 3W. We transpose this one to the left side. And then this 12 here, we put that to the right side. It becomes negative 12. 36 minus 12, that is 24. Now, with the first equation, L equals W plus 56. Okay? Now, let us multiply this by negative 1. Why do we need to multiply this by negative 1? So that if this becomes negative L, it will cancel out to this L in the second equation. Okay? Okay, let's do that. Negative L, negative L equals negative W minus 56. Okay? Now, what we can do also is that this negative W, we put this on the left side. Alright? If we put this on the left side, it becomes positive W. So, let us erase this one here. Let us put here positive W. And then, let us align this negative 56 to the constant. Alright? So, that is what we can do. Actually, you can transpose it first here before multiplying by negative 1. It's just the same. Alright, so these are our working equations. We can cancel out L by addition. We add these two variables here, so that will become negative 2W. Also with this, we add this. So negative 56 plus 24 is negative 32. Alright? So divide both sides by negative 2. So that will give us W equals 16. So, the age of the wooden statue is 16 years old. Okay? Now, from this first equation, we can see that L L is equal to W plus 56, and W is 16. Therefore, L is equal to 72. So the present ages, we can write the answers. The present ages of the statues are 16 years for wooden and 72 years for limestone. Alright, so this is our final answer. Alright, number 4. An engagement ring is 95 years old and a wedding ring is 55 years old. How many years ago was the engagement ring twice the age of the wedding ring? So we can see here two ages being given already. The engagement ring is 95 years old. The wedding ring is 55 years old. So this is the present age. How many years ago? So years ago that we do not know, X years ago, that means minus X of the present ages. So 95 minus X and 55 minus X. Now we can see in the second sentence that the engagement ring twice the age of the wedding ring. So this is the age of the engagement ring. So that's 95 minus X, which is twice the age of the wedding ring, twice of 55 minus X. So there's only one variable here. And then we can solve for this by first distributing 2. So that will become 110 minus 2x. We can actually transpose 2x, negative 2x to the left side. It becomes positive 2x. So if it becomes positive 2x, 2x minus x, that will give us x. And 110 minus 95. So 110 minus 95 is 15. Okay? So what we are looking for here is 15 years ago. So our final answer is 15 years ago. Alright, so that's all for age problems. I hope you understand the techniques of solving age problems, and you can apply this into more age problems that you can encounter in the future. Please subscribe and hit the notification bell if you haven't done yet. And thank you for watching, and I hope you get to watch all other videos that I already have uploaded. Thank you once again.